Okay, we are back for the daily Leetcode challenge. We are doing 1493, longest subarray of ones after deleting one element. Given a binary array, so there's only going to be ones of zeros, you should delete one element from it. Return the size of the longest non-empty subarray containing ones in the resulting array. Return zero if there's no such subarray. So output is 3. After deleting the number in position 2, 111 contains 3 numbers with values 1. You should delete only one element from it? I'm a bit confused. Okay. After deleting the number in position 4, so deleting this, the longest subarray with ones in it is 1111111. Got it. So we're looking for the longest subarray if we removed one value, essentially. And essentially what we want to look for here is, we had a similar problem to this actually with like boxes and things like that, but we're essentially looking for the longest continuous ones if we could skip a zero. And essentially we could do this greedily where we could we can just go through it, and we're gonna have some tracker, but essentially you have a thing where you say, um, you keep track of like the last zero you've seen. Um, yeah, and so essentially it's a little weird with the zero being zero first. But imagine this example, you have 1, 1, and then you see a zero, and you could say, okay, that's the first zero I've seen, or the newest zero I've seen. We are going to take that into account, and then we're going to go on to the next value. And then if you see another zero after that, that means that it's the end of the smaller subarray. That means that you've hit the limit. But if you see another one, that means you can continue going on. And then if you see another zero after that, that means that the length now gets moved from here to here for the new value. Um, yeah, actually, so I think it's just easier sometimes to just code it up. A little makes a little more sense. Sometimes a little bit hard to explain these, but I'm gonna do this. It's just gonna take a pretty much a for loop. We're gonna have some sort of like position counter for the zero, like gonna have to equal. I hate setting it to none, but it's like really what it is. So then essentially what we'll do here is that if we see a, we have to keep it. Um, yeah, I guess we could do a max len here. Essentially, if nums of I equals a 1, pretty simple. We just want to do. We might be able to get away with not doing this, but I'm just going to do it for now. Um, you must send it to 0 actually. I'm gonna move position. I'm gonna make it pause. Um, yeah, position 2. Yeah, it's gotta be +1 there. Be inclusive. I don't love that actually. It's gonna be -1. I'm gonna make it -1. Yeah, I'm not sure. I'm gonna think about that a little more. Okay. Um, but if it's 0, we'll come back. We'll come back to that. It's just these are some weird edge cases here. If nums of I equals 0, that means that the 0 pos gets sent to I. Oh wait, I think I see it actually. Okay. 0. I think we want to do a sliding window approach here. So essentially what we'll do here is we'll keep track of the left. And then since we see a 0 now, if nums of left equals 0, which it might not. Hmm. This is a little bit. This is tricky. This is tricky. So this is weird. The max length is 0. So here you would go through here. You see a 0, and I guess that's fine. Like, got it. So if the last scene 0 is -1, continue. That means we saw our first 0. In that case, we do want to set it to I here. And then continue, skip that. But if we've seen a 0 already, we first want to recalculate the max len. I think we can continue here actually. But the max, we could either take the max len, or it's going to be where we are currently minus last seen 0. We'll have to think. We'll have a base case at the end, just in case we don't run into any zeros. But yeah, it would be last place. It would be this essentially plus 1. Uh, so let's say we're on. It would be we found the 0, so it'd be 0. What is this? 1, 2, 3, 4, 5, 6, 7. Or 0, 1, 2, 3, 4, 5, 6. So it'd be 7 minus 1, which is 6. And minus another 1 because you don't want to include the 0 in the calculation. It's actually minus 2, I think, but we're offset by enough. Okay, yeah, we'll have to worry about bounds there. And then last scene 0 gets set to I. Yeah, I think that's right. And now we don't need this left. And if it's all 1's, we're going to get a wrong answer. And so, but that, like, or not that we're not going to get it wrong. We're going to get, I guess, guess we can have a curl line here, right? And then return either the current len or the max len. Well, that's not going to be right. This curl len's kind of like a base case. I don't love it. Because what I want to do here is if you only see 1's, I guess you can like reset curl len here. It's kind of like a cheat and then just take the max here. It's kind of like doing 2 problems at once. I think there's definitely an easier way to solve this, but you know, going through my thought process live here. I'm just gonna submit. Let's see here. Why is that 2? You must delete 1 element. That's weird. Oh gosh. That's really weird. Alright. That's funky. Okay. Is there a better way to do this than using like curl line? I'm actually gonna put curl line here. And then it's gonna be off by 1, right? Not exactly because this is right because it only adds to curl line when there's 1's. This example, we get 3. So we see a 0 off the bat, so we get set to 0. And we see 3's. Then we see another 0. Then it's like, okay, let's reset curl line. But no, we don't want that. We want to keep track of the fact that now left equals don't think we need this curly line when we have this left thing now. So I'm keeping track of the left value, and I'm making sure that if we see a 0, we go to the next value. Sorry, if left is not equal 1 and left equals last seen 0 plus. Sure, I can just equal its last seen 0. And then obviously we'll just go through the loop once. And then last seen 0. We set to right. Let's run that. I think this is obviously going to be wrong because it's got to do this here, left, and then we can delete this. Maybe this makes more sense. I don't think we need the -1 here anymore. Any infinite loop here. Okay, I like the answer so far. We got the right answer here. We're not getting the right answer here because we're never getting into this check. We should put this check here. Or here, actually. Or no, wait. Yeah, I think we just got to do this like here. This could stay. I don't think it matters where this goes. No, actually, yeah, this could just go here. And then essentially, we have to do this again. Either the max of the length. Essentially, we're treating it like it's -1. Well, we can just do this. Well, be clear. -1 minus left -1. Because the last index we see, it might be, yeah, I think that's fine. And then minus where we last left off, and then -1 just to be consistent. We're getting 2 here. Maybe we don't need to -1 here. It's a little confusing, but I'm not 100% confident on the solution. Yeah. Yeah, so I see. Double zeros is weird. It's a weird case. Just remove this to be honest. If you have double zeros, what's happening here is that I don't know exactly actually. Left is probably here, right? So we get 0. We get 1, 2. Three. Do we have a zero there? What do we have a zero there? Why is this such a hard problem? I don't know. I'm gonna do this. Let's get some. Let's see what the array is indexing here. So get one, and then we get 1 1, then we get 1 1 0, then we get 1 1 0 0. Then we're like, shoot, get this zero out of here. Right, because left. See, this constraint is fucking it up. Then we get zero. Yeah, I see. I see the issue. So, okay. The double zeros. I'm gonna have to delete this fucking. I'm gonna have to delete this for loop, which I don't want to do, but. All right, so right equals 0. And what we're doing here is we're trying to get this. This should never have any. If there's two zeros in a row, it should never be like that. Wait, that shouldn't matter though. Wait. So if we see a 0, sorry, wait. Nums of left. Shouldn't, if does, oh my gosh. Oh my gosh, I can't believe I messed that up. Now we're passing on the cases. Okay. Yeah, that was a silly mistake. Okay, that was, there's like weird edge cases to this problem that I don't love. It took me a little bit longer than it should have, but that was pretty much it. A lot of don't love my solution to this problem, but it's relatively clean. It's a sliding window at left, and then there's a bunch of weird edge cases. I just want to see something if let's just see if anyone has some nice solutions. Or is everyone kind of, let's see what they did here. Yeah, I mean, a little bit better than what I did here, zero count. Um, did anyone use their problem from 1090? Wait. Um, sliding window. How did they deal with like the window specifically? Nums equals 1, r minus m. Oh gosh, it's a little confusing here. This guy's got like no, I don't know what L, K, and M are. I mean, I can look, but I don't care. Yeah, C++. One loop solution. Jesus Christ, look at this. This is really complex. I think this guy's a zero flag as well. Let's quickly look at this again. I think this is like the cleanest. So they have a zero count, and then they also have the longest window count. Left, and then they have a left of the window. So that's exactly what we have. Well, we don't have like a current count. So then they go through each one, and then the zeros counts equals. I mean, they have the zeros count. Okay, so yeah, they count the zeros. If oh, it's kind of smart actually. If the count of zeros is greater than one, move it over. Ah, it's yeah. This is actually the much better solution. Yeah, than having to do this BS. But essentially, I'm doing this. But you have a window, and then once the zero count is greater than one, this is the superior solution actually. Yeah, yeah, yeah. This is much better. Okay, valid. Well, this is still it works. I think I should have came up with that solution. I should have a sliding window counter that keeps count of the zeros. Okay, that's valid. I learned. I know for the next time. Thanks for watching, everybody. See you tomorrow.